Hey everyone, Hihu here from LeetCode. Imagine a classroom full of students. Two students can absolutely score the same marks. There's nothing wrong with that. But today, we're not interested in the marks themselves. We're interested in how many students scored each mark. And here's the challenge. Every frequency must be unique. That's exactly what today's problem is asking us to check. Today we're solving LeetCode 1207, unique number of occurrences. It's an easy problem from the HashMap and HashSet section of the LeetCode 75 study plan. At first glance, it looks like we're working with numbers. But the real focus of this problem isn't the numbers at all. It's the number of times each value appears. Once we realize that, the solution becomes much easier. So before thinking about the algorithm, let's first understand the problem. We're given an integer array called R. Our task is to check whether every distinct number appears a unique number of times. If every frequency is different, we return true. If two different numbers have exactly the same frequency, we return false. Notice something important. The numbers themselves can repeat. There's absolutely no problem with that. The only thing that must be unique is their frequency. Let's understand this with an example. Suppose our array is 1, 2, 2, 1, 1, 3. Let's count how many times every number appears. The number 1 appears 3 times. The number 2 appears 2 times. The number 3 appears 1 time. Now forget the original array for a moment. Instead, just look at the frequencies. 3, 2 and 1. Are all of them different? Yes. So the answer is true. Now let's look at another example. Suppose the array is 1, 2. The number 1 appears once. The number 2 also appears once. Now the frequencies are 1 and 1. Since the same frequency appears twice, the answer becomes false. Now the obvious question is, how do we efficiently count these frequencies and verify that they're all unique? Let's begin with the most straightforward approach. The first idea is pretty straightforward. For every distinct number, we can count how many times it appears in the entire array. Once we know all the frequencies, we compare every frequency with every other frequency. If two different numbers have the same frequency, we immediately know the answer is false. If every frequency is different, then the answer is true. The idea is simple, and it definitely works. Now let's see how we'd implement it. We begin by picking one number from the array. Then we scan the entire array to count how many times that number appears. Next, we pick another number and repeat exactly the same process. After we've calculated all the frequencies, we compare them one by one. If any two different numbers have the same frequency, we return false. Otherwise, after checking every frequency, we return true. The implementation isn't very difficult, but let's verify it with a dry run. Let's use the same example. 1, 2, 2, 1, 1, 3. We start with the number 1. Now we scan the entire array. We find that 1 appears 3 times. Next, we move to the number 2. Once again, we scan the entire array from the beginning. This time, we find that 2 appears 2 times. Now we repeat the same process for 3. After another full scan, we find that it appears once. At this point, we know all the frequencies. 3, 2 and 1. Now we compare them. 3 is different from 2. 3 is different from 1 and 2 is also different from 1. Since every frequency is unique, the answer is true. The algorithm works correctly. But did you notice something? We scanned the same array again and again and again, even though we'd already counted those numbers before. Let's analyze the complexity. Suppose the array contains n elements. For every distinct number, we may end up scanning the entire array to count its frequency. Then we compare the frequencies with each other. Overall, this approach can take O of n squared time. Now let's talk about space. Apart from storing a few counters, we don't use any significant extra memory. So the extra space complexity is O of 1. The real problem isn't memory. The real problem is that we are repeatedly counting the same numbers. Can we somehow count every number just once? Let's pause for a second and think about what we are actually doing. Are we interested in the original array? Not anymore. The moment we know how many times every number appears, the original array has already served its purpose. From this point onward, we don't care whether the number is 1, 2 or 3. We only care about their frequencies. That's the first breakthrough. So instead of counting the same number again and again, why don't we count every number just once? A hash map is perfect for that. It lets us store every number along with the number of times it appears. Now comes the second question. Once we have all the frequencies, how do we check whether they're unique? Again, we don't need complicated comparisons. We simply need to know whether we've already seen a particular frequency before. And that's exactly what a hash set is designed for. If we try to insert a frequency that's already present, we immediately know that two different numbers share the same frequency. That's the second breakthrough. So the problem naturally splits into two simple steps. First, count every number. Then, verify that every frequency is unique. Our algorithm now becomes very clean. We start by creating a hash map. Then we go through the array once and build a frequency table. By the time we finish, every distinct number is mapped to the number of times it appears. Now we create an empty hash set. Next, we iterate through all the frequencies stored inside the hash map. For every frequency, we try adding it to the hash set. If the frequency wasn't present before, everything is fine and we continue. But if that frequency already exists inside the hash set, we found a duplicate frequency. That immediately tells us the answer is false. If we finish checking every frequency without finding any duplicates, then every frequency is unique. So we simply return true. Now let's translate this idea into code. Now let's turn that idea into code. First, we create a hash map to store the frequency of every number. Then we traverse the array once. For every value, we either insert it into the map or increase its existing count. By the time we finish, the hash map contains a complete frequency table. Now we create an empty hash set. Next, we iterate through all the frequencies stored inside the hash map. For every frequency, we try adding it to the hash set. If the insertion succeeds, it means we haven't seen that frequency before, so we simply continue. But if the insertion fails, that means the frequency already exists inside the hash set. In that case, two different numbers share the same frequency, and we immediately return false. If we finish checking all the frequencies without finding any duplicates, we return true. Let's walk through the same example one last time. Our array is 1, 2, 2, 1, 1, 3. We start building the frequency table. The number 1 appears 3 times. The number 2 appears 2 times. The number 3 appears 1 time. So our hash map now contains 3 entries. 1 maps to 3, 2 maps to 2, and 3 maps to 1. Now we create an empty hash set. Let's start checking the frequencies. First, we see 3. The set is empty, so 3 gets added successfully. Next, we see 2. 2 isn't present in the set, so it also gets added. Then we see 1. Again, it doesn't exist in the set, so the insertion succeeds. We've checked every frequency, and none of them were duplicated. That means every occurrence count is unique, so the answer is true. Now let's see a case where the answer becomes false. Suppose the array is 1 and 2. Our frequency table becomes very simple. 1 appears once. 2 also appears once. Now we start inserting frequencies into the hash set. The first frequency, 1, gets added successfully. When we try to add the second frequency, 1 already exists in the set. That immediately tells us we found a duplicate frequency. So we return false. Let's analyze the complexity. We make one pass through the array to build the frequency table. Then we make another pass through the frequencies stored in the hash map. Each number is processed only a constant number of times. So the overall time complexity is O of n. Now let's talk about space. The hash map stores the frequency of every distinct number. The hash set stores the frequencies we've seen so far. In the worst case, Both structures can grow proportional to the number of distinct elements. So the space complexity is O of n. Let's quickly recap. The brute force solution kept counting the same numbers again and again. The breakthrough came when we realized that the original array wasn't the important part. The frequencies were. Once we built a frequency table, the problem became much simpler. Now we only had to answer one question. Are all these frequencies unique? A hash set gave us an efficient way to verify that. That's the interview pattern to remember. When a problem asks questions about how often things appear, start by building a frequency table. Once you have the frequencies, many problems become much easier to solve. And that's how we solve LeetCode 1207, unique number of occurrences. If this explanation helped you understand the idea, don't forget to like the video and subscribe to LeetCode. Thanks for watching. This is Hihu signing off. Keep practicing and I'll see you in the next one.